Kia ora, Year 11 and 12. In this video we're going to look at how we can write the equation of a line in the form that we're all familiar with, y equals mx plus c. So this is our favourite way to write lines because it lets me easily see how to draw them. Let's take an example, y equals 2x plus 1. So when we first learnt about drawing straight line graphs, we would have started way back with a little table where we had the x values and the y values, and we could plot points to get our coordinates and then join up the points. And we really only need two of them, but usually we would have done something like this: -2, -1, 0, 1 and 2. So let's start with what happens when x is 0. If I substitute that in here, I get 2 times 0 plus 1. So this number on the end, the plus 1, which is the plus c in my general case, is going to go on my graph here. Now let's put a few more in. We're only going to do this for this one. If I substitute in x equals 1, I get 2 1s plus 1, which gives me 3. So the coordinates of the next point I'll work with are 1, 3. If I put in x equals 2, I get 2 2s plus 1, which will give me 5. So let's put those points on now and see what's going on. It'd probably be a good thing if I put some numbers on my graph. So I won't number all of them, but 1, 3, 5, 7, and so on. Right, so we can plot point up here. 1, 2. It's rather unconventional ordering, but that's okay. Let's put our points on. So we've got 1, 3 sits here, and the next point is at 2, 5. So this is revision from earlier years as well. I've got my gradient here, which is the rise over the run. So I can take any 2 points and work out the ratio of the vertical change over the horizontal change. So m is the change in y over the change in x. And in this case, I'm going up 2 every time and out 1. And that number comes from here. So it's a really good skill to be able to turn any straight line equation into one that's in this form here. Now I'm just going to finish off drawing that equation for you, so we'll just get the ruler out quickly and we can join those dots up. Let's see if this works. So there we go, we've got our 3 points, we just need 2, and now we will join up the dots with a nice red line. There we go, so that's my equation there. Just a couple of other things on equations. When you're drawing them, just remember to make sure that you don't just draw in a little bit of the graph. We want to give the idea that that equation goes on forever and ever in both directions. So that's all good. We remember, hopefully, that this is the way we want our line, and all we have to do to get there is a little bit of algebra, your favourite part of maths. So we're going to do some examples now. Make sure that you've got your pen and your book out so you're ready to work through these with me. Once you're finished, or once you feel like you've got it enough, there's a really good exercise in theta 105, and just do questions 1 and 2 because we haven't learnt the next skill yet. Okay, so the first one we'll look at is this equation. So 4x equals 2 plus 5y. Now for some reason we might have ended up with that as the end of a problem, and we know that it's going to give me the equation of a straight line. So how do I get it into y equals mx plus c form? Well, I'll do 4x take away 2 equals 5y. Divide both sides through by 5, and we get 4/5 x minus 2/5 equals y. So the gradient m is equal to 4/5, and the intercept c is equal to -2/5. Right? Always remember the sign goes with the number. So now we can sketch the graph. Now sketching the graph for ones like this is actually a bit harder than it looks, and you'll see why as soon as you look at that intercept. So it's -2/5. So this is a pain in the neck because it's very hard to put that directly on my graph unless I change the scale on my graph, which will make it a wee bit easier. And I'm going to do one like that now so that you can see. So if I make every square 1/5, then down here we've got -1. Right, we don't have -5. And out here We count out 5 dots, so here we've got 1. So now I can draw a nice accurate graph. So negative 2/5 is going to be this point down here, and my gradient is going up 4 and out 5. Now that will still work out 4/5 and up 5/5 if I count squares. So first we go across 5, 1, 2, 3, 4, 5, and then we go up 4, 1, 2, 3, 4, up to here. And we're going to join those up now. Right, so just going over that again, I've changed the scale on my graph to make it easy to get an accurate graph here. We'll put the ruler in and we'll join up the points. So joining up, just need 2 points to draw the line, and here it goes. There. Okay, so I know that was a bit slow. It's really good to get some practice in it drawing graphs here. So that gives me an accurate graph because of how I changed the scale. So if I didn't do that, I'd have to estimate negative 2/5 and estimate my slope. And for many purposes, that'll be fine. The main skill I want you to get in this anyway is the algebraic one, but we are going to be doing lots of graphing along the way, so it's both. So that's my rewritten equation. This is my gradient, and this is my intercept. So we'll do a couple more, and they'll gradually get harder. Okay, so let's look at a line in this form. X minus 5y plus 7 equals 0. X plus 7 equals 5y. Divide through both sides by 5. And we get x over 5 plus 7 over 5 equals y. Now that's okay, and many of you will be able to read off the gradient when it's written like this, or we could write it like this, which I think is slightly nicer in this context. So 1/5 x plus 7/5 equals y. So my gradient in this case, m, is equal to 1/5, and my y-intercept is equal to 7/5, which is the point 0, 7/5. So this time I'm going to show you what it's like when you draw that graph without a good bigger scale, and you'll see that it's a bit trickier. So we're going to start with the y-intercept, which is at 7/5. So that's about there, right? So it's quite hard to get it accurate. And now we have to do the gradient to find another point. We're going to go out 5 and up 1. 1, 2, 3, 4, 5. And up 1, so we still want to be just under halfway through. So it's a positively sloped line, but a very flat one. Let's put in the ruler, join the dots, see how it looks. Now I need to label my graph as well. There we go. Let's draw that in now. Right, so notice again that I'm doing my line to go right out to the edge of the graph. Cool. Okay, now the last thing I've got to do is put some numbers on there. This is no use as it stands. So here, this point here is 7/5, and I'm just going to label a few points on my axis to make it clear. So that's 4 there, just enough to let the reader interpret your graph. So here we've got 2, 4, 6, and so on. Don't put the dot dot dots. Alright, so that's that one. For the next couple, I'm not going to do the graph, I'm just going to do the algebra, otherwise you'll be watching this video for way too long. Right, so the next question is a little bit harder, and I've modelled it on one of the nice questions in the theta book. Suppose that now we've got an equation with coefficients that we don't know. Okay, so we've got kx, py, and d. We want to rearrange this one to find the gradient and the y-intercept. So we work just as we did before. K, P and D are still just numbers that we happen not to know. So Py is equal to negative Kx minus D, and then Y is equal to negative K over P, X minus D over P. So let's go over the steps that I did here again. I'm trying to make Y the subject, so I keep the thing with the Y's on this side. I subtract Kx from both sides, and I subtract d from both sides. That gets me to this line here. Now I just want y, not py, so I divide everything through by p, and that gives me negative k over p, x minus d over p. So my gradient, m, is equal to negative k over p, and my y-intercept c is equal to, let's keep that negative sign there with it, negative d over p. I think it's question 2 in the theta book is very, very similar to this, so make sure you do that one. Okay, that's all for now. Thanks for your patience in watching, and well done if you made it right to the end. Go and try questions 1 and 2 in the theta book. Every second question will be fine.